Hi friends, welcome back to Team Education. Friends, in this video we are solving how to find the limits in two-dimensional space. This is a very important topic, especially to find the area in the given region. Also evaluate the Gauss divergence theorem, means evaluate the surface integral or else Stokes theorem applications. In that cases it is very useful. Moreover, in the multiple integral, sometimes they will give a region and changing the order of integration also they will ask, because in this case I will do both the regions. One is x is independent variable. If they are given, if we are changing the order of integration, we have to convert y as independent variable. That also I will explain. So this is a very important concept. Those who are having a multiple integrals and vector integration. Okay, right, coming to the video. In this video what we are discussing, first finding the limits for the given region. First one is a triangle. Friends, you remember sometimes they will give directly the triangle points a b c. Sometimes they will give intersection with the coordinate axis with x plus y is equal to 1 line, or else some other line they will give. Okay, in that case you will get the triangle. Next, full circle. Next, upper half of the circle limits what you have to take, and first quadrant limits what you have to take also we are discussing. Next, third one is ellipse. In the ellipse, if I explain the total ellipse, you can identify easily what we have to take about the first quadrant. Okay, limits of the first quadrant. Next, here you observe I gave a parabola intersection with the straight line. Parabola intersection with the straight line. Next, parabola intersection with the x ordinate and y ordinate. X ordinate and y ordinate, here you they are given not y ordinate directly, like x is equal to some constant, x is equal to a, x is equal to a, like that. So in the previous case straight line they are given directly, but in this case they are saying about the ordinates. Next one, here you have a two parabolas, intersection with the two parabolas. So if you are understanding this video, then you can solve the problems very easily in the exam. Moreover, you remember friends, maximum of the topics I covered in xy plane, that too in a two-dimensional space. Maybe if suppose if I missed anything, based on this knowledge you can do very easily. Okay, now coming to the first problem what we are going to discuss. You see friends, evaluate the double integral over rx square y square dx dy over the region in the positive quadrant for which x plus y less than or is equal to 1. Friends, here you observe I gave only problem, but I am not doing the total solution. What I am doing, just how to find the region, given region limits, how to find the limits for the given region. Okay, now here what they are given, first you observe this is a positive quadrant. Next, moreover x plus y less than or is equal to 1. So this is our region in the positive quadrant, and that should be which line, x plus y less than or is equal to 1 line. So first I am drawing x axis, next y axis. Now here you observe less than 1 means x plus y is equal to 1 and x plus y less than 1, both are there. What is mean by x plus y is equal to 1 line? X plus y is equal to 1 line is, here you observe this is the x plus y is equal to 1 line. Now what about the x plus y less than 1? This is a greater than 1, this is equal to 1. On the line is equal to 1. Greater than line, above the line means upwards is greater than 1. Okay, downwards means less than 1. So our region is like this, total region you have to take. But what they given in the first quadrant only, not like total, we required only in the first quadrant. So this is our region. Okay, this is our triangle right now. In this triangle, now what you require to find, limits you require to find for the x and y. You remember friends, one of the important thing is when you will get to independent limits for the given region. This is what rectangle. Next, this is a square. Friends, you remember, if the given region is either square or rectangle, then only you will get x limit is from a to b and y limit is from c to d. In this case you can say a, b, c, d are constant. Also you can say independent limits. Next, in any other region in the two-dimensional space, you will get only which one? One is independent, another one is dependent. Okay, that is the most important concept. I repeat again, you see, if it is a square or rectangle, then only you will get the limits of the limits in the two-dimensional space, both are independent. In rest of the all other cases, what will happen? one is independent variable, remaining are dependent variable. Okay, this is in 2D. Okay, two dimensional only we are doing. Now here friends, you remember I can take x limits as independent. Next, if x is independent, then obviously y is a dependent in this triangle. This is the region 1, region 2. When the region 1, region 2 we have to use. Friends, to evaluate this integration, you can use any region. Region 1 you can do, or region 2 you can do. In the region 2, first you have to take x as a dependent, y is independent. Here you x is independent, I am taking here x independent, y dependent. Next, in this case, I am taking x is a dependent, y is independent. Now in this problem only I am going to explain these two regions. Rest of the regions only I will explain one region. What is the use, sir? If I did in region 1 or region 2, you will get the same answer. But the thing is, you remember, sometimes to evaluate the double integral, it is to evaluate these type of the integrals, we cannot get directly solution. In that case, we use change of order of integration. One of the important topic in the multiple integral, must and should you will get one question. That is the reason only I am going to explain two regions in this problem. Okay, now in this region, one is independent variable. Okay, first you see friends, what they are given, x plus y is equal to 1. Next, here you know that this is a 0 comma 0. To get y value, what you have to do? Put x is equal to 0. If you put x is 0, whatever the y? 1. So 0 comma 1 is this point. Next, if I require x value, what you have to do? Put y is equal to 0. Then you are getting x is equal to 1. So 1 comma 0 is the point. And this is the line. Which line? X plus y is equal to 1 line. Now I required this region. Okay. So first I am taking x as independent limits. You observe friends, here what is the x limit? 0. X axis means, along the x axis means, here the point is moving, the region is moving from A to B. A is you observe, A is a 0 comma 0 point. X value is 0. Here x value is what? 1. So x is moving from 0 to 1 only. So you can say x lower limit is 0, upper limit is 1. Next, in this case, you observe 0, 0. So y is not moving, only x is moving, right? Next, y value you require to find. Y value if you want to find, friends, if you taken like 0 to 1, this is wrong. 0 to 1 if I taken, what will happen? This is independent, x and y are both are independent limits. In that case, it should be what? It is a square or rectangle. But is it a square, friends? No, it is what? Triangle. So you have to take one is independent, remaining are all dependent. So how can I take y values in terms of x? Means draw the strip which is parallel to the y axis. Now this strip is touches the x axis. Downside it is touches the x axis. On the x axis, y value is what? 0. So y lower limit is 0. Next, upper limit I need to find. So this strip is touches upwards which curve? The line. Which line? X plus y is equal to 1. What is the line value? Y is equal to 1 minus x. That's it. So write on y is equal to 1 minus x. So this is a region 1. In the exam, sometimes they will give, instead of this region, x is from 0 to 1, y is from 0 to 1 minus x. Evaluate this one by change of order of integration. Means you have to convert into region 2. What is the region 2? In this case, you have to take x is a dependent, y is independent. Now I am going to explain that. In the region 2, x is I am taking as a dependent, y is I am taking as an independent. So here you observe, y independent means y limits you have to find out first. So along the y axis, what is the point here? You have 0, 0. Next ending point is 0, comma 1. So x is 0, x is 0. So x is doesn't change. Y value is from 0 to 1. So y is moving from 0 to 1. Okay. So y independent limits you have 0 to 1, friends, here. Next, you require to find x limits. How can you get x limits here in this case? Draw the strip which is parallel to the x axis, because we required x limits now. So for the strip is touches left side which curve? Y axis. On the y axis, x value is what? 0. That's it. Next, right side it is touching the straight line. What is the straight line name? Equation is x plus y is equal to 1. Now this line is required in terms of what? X. So write down x is equal to what? 1 minus y. So x is here 1 minus y. So this is a region limit. In this case R1, in this case R2. What are the different cases here? In this case, x is independent, y is a dependent. Here you have x dependent, y independent. So if you are understood this problem clearly, you can solve changing the order of integration method very easily. Okay. Now what I did now? Triangle. Next, go for another one. here you observe evaluate the double integral over the circle, total circle friends. So x-axis, this is the y-axis. Next I am taking the circle with the name x square plus y square is equal to 1. Okay, now you observe friends, here they are given over the entire circle. Entire circle means in the 4 quadrants you have to take. Now I want r limits. Friends, you see x square plus y square is equal to 1 they are given. If you want x value, what you have to do? Put y is equal to 0. Put y is equal to 0. Then x square is equal to 1, which implies x is equal to plus or minus 1. Next, if you want x values, I mean y values, put x is equal to 0. That implies y square is equal to 1, which is implies y is equal to plus or minus 1. Okay. Now, region 1. Region 1, x I am taking as an independent, y I am taking as a dependent. Okay. Now, x limits I want. First, you draw the, plot the values here. So, this is origin, friends. Next, here you observe x is moving from minus 1 to plus 1. So, this is a minus 1 comma 0. On the x-axis, y value 0 na. So, here 1 comma 0. And here what you have? 0 comma minus 1. Next you have a 0 comma 1. So 4 points are clear. Now over the entire circle I want. So x is moving from this point to this point. So what about the x values here? Tell me. Left side you have minus 1. Here you have 1. So x is moving from minus 1 to plus 1. Lower limit is minus 1. Upper limit is 1. Next I want y value. Here I have to take y is a dependent, not independent. Don't take directly like this. Okay. Now draw the strip which is parallel to the y-axis. So I can say this is the strip. Of course, this is the strip. Both the strips are equal. In this case, what? In this case, what you have to take? Even the strips are parallel to the y-axis, but the value will be different in this case. Yes or no? So if you draw the parallel to the y-axis like this, you have to draw entire. Okay, now friends, because it should be cover the total region. Now what you required? I required y limits. Now tell me what about the lower curve? This is a circle. Upper curve is also what? Circle. So y square, x square plus y square is equal to 1 you have. Right? And y square is equal to 1 minus x square. Now convert into y values. So square root if you are applied, then I will have plus or minus root of 1 minus x square. So the lower curve is you will get a negative of root of 1 minus x square. Upper curve is plus root of 1 minus x square. So minus root of 1 minus x square to plus root of 1 minus x square. That's it. So these are the x and y limits. Now you try with row 2. Row 2 what you have to get I will tell you directly. Y limits are from minus 1 to y limits are minus 1 to plus 1. X limits you have to get minus root of 1 minus y square to root of 1 minus y square plus root of 1 minus y square. So friends, if you are getting this answer, please write in the comment section. I will verify if you did a correct answer or not. Okay. Next, compute the region where R is the region bounded by the circle, but here you have a first quadrant only. Region in the first quadrant. First quadrant means first I am plotting the x ordinate. This is the x axis. Next y axis. So this is a total circle I am taking. No, only I am taking the in the first quadrant. So the coordinate in the first quadrant circle is name is what? X square plus y square is equal to a square. So you know that this is a 0 comma 0. And what about this? If I want x value, what I have to do? Y value you put 0. So x square is equal to what in this case? X square is equal to a square. X is equal to plus or minus a. So in this case a comma 0. Am I required minus a comma 0? No, because the region is in the first quadrant only. Next I want y value. Similarly, what you will get y value in this case? Here 0 comma plus a. This is the point you have 0 comma plus a. This is the point a comma 0. Now here 0 comma 0. So this is our required region. In this region I am taking x limits are independent, y limits are dependent. How can I get x limits here? Where it is moving? From the origin to a. So x is moving from 0 to a. Next y value required to find. Draw the strip which is parallel to the y axis. So this is the strip you have, friends. In this strip, tell me lower curve is what? X axis. On the x axis y value is what? 0. Next upper curve is what? Circle. What is the name here you have? X square plus y square is equal to a square. So y square is equal to a square minus x square. Y is equal to plus or minus root of a square minus x square. But in the first quadrant y will be a positive. So it should be root of a square minus x square. So this is the region 1. Now you convert into region 2. Region 2 you have to get like this. Directly I am writing y is from 0 to a, x is 0 to root of a square minus y square. So friends, you try this one. If you are getting the same answer, please write in the comment section. Okay. Now coming to the next problem. Compute the double integral over r y dx dy where r is the region in the first quadrant bounded by the ellipse. Bounded by the ellipse. Ellipse na? Okay. Circle completed. Now ellipse. Here you observe this is the x-axis, this is the y-axis. Now ellipse, total ellipse is this one. This total ellipse is occupied in the four quadrants. Okay friends. Now you require to find the limits. Now I am taking x limits are independent and y limits are dependent na. So in this case, how can I get x values? Put y is equal to 0. Then x square by a square is equal to 1, which is implies x square is equal to a square. X is equal to plus or minus a. So x is moving from where to where? Here you have a left side and right side of the x-axis. So this is, you can say, minus a comma 0, and this is the point a comma 0. So x is moving from minus a to plus a. Next I require y limits. You have to take y limits if you put x is 0, what you will get here? Y square by b square is equal to 1, y square is equal to b square, then y is equal to plus or minus b. If you written minus b to p, that is wrong, because that is not a rectangle or square. It is a ellipse. It is an ellipse. So what you can say, here you have to take y is a dependent limits. So you have to write like this: y square by b square is equal to 1 minus x square by a square. So y square is equal to b square into root of 1 minus x square by a square. Sorry, here 1 minus. Okay. So y is equal to, you will have, I will write here, y is equal to plus or minus b into square root of 1 minus x square by a square. So y is, how can I get y limits? Draw the strip which is parallel to the y axis. If you draw this strip is touches the downside the ellipse only. Okay. Upwards also ellipse only. So in this case, ellipse value is what? Y value is what here? 1 minus x square by a square. In this case, y is equal to plus b into root of 1 minus x square by a square. So y is moving from minus b to root of 1 minus x square by a square to plus b into root of 1 minus x square by a square. So this is a region 1. So can you write a change of order of integration? Nothing but r to region 2 you can write easily, no? Yes. Try to solve. If you are getting the answer, please write in the comment box. Next problem. So friends, here you observe, here evaluate the region R between y is equal to x square and y is equal to x. You know that if x square, even powers of x is there, directly you can say it is a positive. Quadratic equation is nothing but a parabolic equation, parabola. Y is equal to x means a straight line, degree 1. So now this is x axis and this is y axis. This is y is equal to x square and it is y is equal to x line. Right friends? Now you required which region? This is our region. This is the region you require to find. So for that you find the limits first. How can I find limits? Here you have a y is equal to x. Put y is equal to x. Then x is equal to what? X square. So take what you will do generally, this one getting cancelled, you will say x is equal to 1. But you remember friends, if you have a degree 2, you have to get 2 roots. So how you can do this? X square minus x is equal to 0. Take x common from these two. Then you will have x into x minus 1 is equal to 0. In this case, x is equal to 0. X is equal to 1. Put x is equal to 0 in this equation. Then what you are getting? Y is equal to 0. Put x is 1. Then you are getting y is equal to 1. So the limits points are what? Intersecting point 0, 0, 1 comma 1. So these two intersecting points values I know. Now you have to find out the x limit and y limit. Here in this case, in this region, I am taking x as an independent limit, y as a dependent limit. So x is moving from 0 to maximum. See here, this one only, maximum this side. What about what you can write? This point is, this point what you can write? Tell me. 1 comma 0. So x is moving from 0 to 1 maximum. Now you required which value? Y value. Y also independent? No. Y should be a dependent. So draw the strip which is parallel to the y-axis. In this strip touches which curve? Parabola. What is the parabola name? Y is equal to x square. So the lower curve is y is equal to x square and the upper curve is a straight line. What is the straight line name? Y is equal to x. So y is equal to x means this is the region 1. If you want, you can convert into change of order of integration. Okay friends. After getting the solution, please write in the comment box, right? Next, now what we discussed with the straight line directly they are given. Sometimes here you observe friends, they are giving a region bounded and a domain bounded by x-axis, x is equal to 2a ordinate, and which is parallel to the y-axis, x square is equal to 4ay parabola they are given. Now x-axis, next one this is x-axis, and next one y-axis, this is x is equal to 2a line, and this is the parabola we have, right? Now what is the region you want? This is our region. Clear friends, this is our region. Now you require to find the points. By the observation we can say this is 0 comma 0. We know that this is x is equal to 2a line, so obviously 2a comma 0. So you got two values. Now I require to find this value only. So what is this value? This is x is equal to a line, this is x square is equal to 4ay. So substitute x is equal to a in this case, then you will have 2a whole square is equal to 4ay. So 4a square is equal to 4ay. So obviously y is equal to what? A only now. So this is the point 2a comma a. That's it. Next, what you want? X limits are independent. Now I am doing region 2. You do it region 1. Generally what I am doing, x as a independent, y as a dependent. Now I am taking a y is independent, x as a dependent. Okay na? Right. Now why I am taking independent means here you observe the region is y value is what here? 0. Here you have a. So y is moving from 0 to a. Next I want x value. So draw the strip which is parallel to the x axis. So this is the strip friends, parallel to the x axis. X axis left side touching the parabola. What is the value of x if it is touching the parabola? X square is equal to 4ay you have. So x is equal to root of 4ay. You can also write 2 root ay. Both are same. Next one, upper limit. Upper limit means right side where it is touching this straight line. What is the straight line name? X is equal to 2a. So this is x is equal to a. Now I did y is independent, x is dependent. You try to solve x as a independent and y is a dependent. If you are getting the answer, please write in the comment section. Okay. Next, last one we are doing a intersection with the two parabolas. X square is equal to y square is equal to x. Okay. Friends, you observe whenever you have a x square term, even powers of x if you have, that is a parabola which is symmetrical about the y axis. Whenever you have a y square, it is a symmetrical about the x axis. Whenever you remember, this is x axis and y axis. Now I am going to draw the parabola. First this parabola, x square, even powers of x, symmetrical about the opposite axis. What is the opposite axis? Y axis. So symmetrical like this. So this is x square is equal to y. Next y square is equal to x. Means generally parabola C type like these types you have. But here y square is equal to x is there. Even powers of y. So symmetrical about opposite axis. What is the opposite axis? X axis. So you will get like this. That's it. Now intersection points 1, 2. These 2 points you need to find. So solve these two equations. X square is equal to y square is equal to x. So put x is equal to y square. Y square whole square means y power 4 is equal to y. I told you already, don't cancel directly. Take like this. Y power 4 minus y is equal to 0. Y you can take common. Y cube minus 1 is equal to 0. So y is equal to 0, comma y cube is equal to 1. So y is equal to 1 comma omega square. But I am taking y is equal to 1 only. So the point what you can say 0 comma 0. And because these omega points are different, that is the reason I am taking real number only. I am taking in this case. Okay. Now this is 1. So if I take an x, y is 0, what I am getting x value 0. If I take an y is 1, y square means 1. So x value is also 1 when you are putting y is 1. So 1 comma 1. Now region 1 I am doing. Region 2 is a homework for you. Try to solve this. X is independent, y is dependent. I am taking. Now x independent means x draw the strip here you observe. Yeah, what you can say up to this only now. This mark only now it is moving 1 comma 0. So x is moving from 0 to 1. Independent I am taking friends. Don't forget. Next I want y value. What I have to do? Y should be dependent. So what I have to do? Draw the strip which is parallel to the y axis. This strip touches downside which curve? X square is equal to y. What is the y value here? X square. So x square 2. Next upwards is what? This curve. What is this curve name? Y square is equal to x. So y is equal to what? Root x. So plus or minus. But you have to take on the first quadrant now. So plus root x. That's it. So this is a region 1. If you want, you can convert into region 2 by using the change of order of integration. So friends, in this video, we discussed about the triangle, next circle. This is the first quadrant of the circle, and full circle. Here you have an ellipse, full ellipse. Even you can do by using this method, first quadrant of the ellipse also. Here you have one parabola with a straight line, parabola with the ordinates, x ordinate, and again one more ordinate. Next here you have a x-axis and ordinate. Here you have intersection with the two parabolas. So if you understood this video clearly, you can do different methods also, even if they are given another region. So what you have to remember here, when they are given a square or rectangle, in that case only you will get xy limits are dependent, xy limits are independent. Rest of all other cases in two-dimensional space, one is independent limit, another one is a dependent limit. One is independent, another one is dependent. What about the three-dimensional? In the three-dimensional space, you remember friends, it should be either cube. Okay, if it is a cube. Okay, next one, cuboid also. In the cuboid, these two cases only, what you can say, xyz are independent limits. Rest of all other cases are dependent. Okay, I hope you understood this topic very easily. So based on this, you can do surface integral, volume integral, surface integral, and Gauss divergence theorem application, Stokes theorem application. Moreover, you can do very easily how to find the area in the given region and change of order of integration. Hope this is clear for everyone. Thank you for watching this video. Please subscribe. Don't forget to comment also.